You should have got your test back. If you didn't get your test back, that means it hasn't been done yet. So come and see me and we'll figure out when you can take it. Those of you on the network, you're not up right now, but should have got it back through email. So if you didn't, let me know. Send me a message and I'll get it back to you as soon as I can. Just like any other test, you can redo the problems you got wrong, turn it back in, get up to half your points back. So please make sure you do that. Make sure you know what you're doing. If you have one that you're not sure of, ask a friend to help you out or come ask me to help you out. I want to make sure they're all right when you turn them back in for two reasons. One, I want to see you get as many points as possible back out of them. And two, I want you to have the right answer and how to do it written down somewhere so you have that to look at later. Okay, so let's look at the problem I had you try up here to start off. The length of a rectangle is 11 more than its width. The perimeter is 182. Find the length and width. So looking at a rectangle, we have length and width. There's a relationship between the length and the width. It is what? The length is 11 more than the width. How would I write 11 more than the width? I'd write it as width plus 11. 11 more than something is 11 added to it. My generic formula for perimeter? Perimeter is equal to 2 times the length plus 2 times the width. What would I do from here?
You know that you're going to be 2 times the length, and the length is 11 longer than the width, so 2 times 11, you're going to want to subtract 22 out of the 182.
Okay, so 2 times the length. The length is W plus 11. So what I'll do is where the L is, I'm going to put in W plus 11. Now your logic would work if you're working through it mentally without doing an equation. That is one of the things you would do to solve it. We don't have W is what we're going to solve for here. We've changed L to W so that we can solve for it. Do we know P? Yeah, the perimeter is 182. Now that we have the equation in this form, what can we do with it? 182 won't change, but we do have a parentheses. And whenever we see a parentheses, it should draw our attention there. We need to do something there first. Is there anything we can do inside that parentheses? No, we can't add W to 11. Is there anything that needs to be done to that parentheses? Yeah, times 2. 2 times W? 2W. 2 times 11 is 22 plus 2W. So we can now recombine, or we can now start combining. Again, nothing's going to happen to the 182. 2W and 2W make 4W. So we got 4W with the plus 22. What do we do next? Minus 22. Very good. Subtract 22. 160 equals 4W. And then divide by 4. So 40 equals W. So all we had to do is we divided by 4 to get 40 equals W. So back up here, W equals 40. And the length is 40 plus 11, or 51. So a width of 40 and a length of 51 units. And that's the type of problem we're going to do a few different variations of today for class, looking at the word problems. We're going to also look at problems like, well, very similar, related to that one, like the length. Can't even come close to spelling that, right? The length of a rectangle is 4 times the width. The perimeter is 380. Find the length and width. I'll give you guys a second to try that one in your notes and see how you do. And we'll come back in a minute. So it says the length is 4 times the width. So the length is going to be 4 times W. So in our perimeter formula, P equals 2L plus 2W. What can we put in here? 380 is the perimeter, so that goes in for P. What else? 2, we're going to replace L with 4W, so it's 2 times 4W instead of 2 times L. And then just plus 2W. What's next? Perfect. 2 times the 4W is 8W. We still have the plus 2W there. Perfect. 380 equals 8 plus 2 is 10W. And then divide by 10. 38 equals W. So that's half of what we need. The width is 38. We need to find the length is going to be 4 times 38, or 132. Any questions? Oops, not 132, 152. Thank you. 152 is better. Okay. A similar problem might look at this, like this. Tim is 4 years older than Chris. Pat is 2 years younger than Chris. The sum of their ages is 38. Find their ages. So this one's a little bit different. We have 3 things that we're looking for here instead of just a length and a width. We have Tim, we have Chris, and we have Pat. Now it works out best if there's one of these values that both of the others are referenced off of. So let's start from the beginning and see if that works out. Tim is 4 years older than Chris. So that implies if we let Chris be K or X or whatever, Tim is going to be what? K plus 4, right? 4 years older. Is Pat referencing Chris as well? Yeah, Pat is 2 years younger than Chris. So Pat is K minus 2. So here it worked out nicely. Both Tim and Pat were defined in terms of Chris's age. So now the sum is 38, which means they add up to 38. So that means K plus 4 plus K, which would be Chris, plus Pat, which is K minus 2, equals 38. From here, we can combine what we can. We have K, K, and K, which makes, think of it as 1K, 1K, and 1K, which makes 3K. Positive 4 and negative 2 make positive 2. Good. That equals 38. From there, what do we do to solve this? Subtract 2. So 3K equals 36. And then divide by 3. K equals 12. Now we still have to go back and make sure we answer our questions. K is 12, so Chris is 12. Tim is 12 plus 4, K plus 4. 12 plus 4 is 16. And Pat is k minus 2, so 12 minus 2 is 10. If I double check, do those add up to 38 if I add them back up? Yes, they do. Good. Well, that one was fairly simple. But what if I have it like this? Steve is 6 years older than Tom. Carl is 4 years younger than Steve. The sum of their ages is 50. Find their ages. Well, we have Steve, Tom, and Carl. Now we're going to start off with Steve is 6 years older than Tom. So what would that tell us to do? Well, we're going to define one of them to be X, or Tom, we'll call it just T for Tom. What are we going to do off of there? Steve is T plus 6. But here's the catch. Carl is not described in terms of Tom, is he? Carl is described in terms of Steve. So Carl is 4 years younger than Steve. So we're going to take Steve, which is T plus 6, and we're going to subtract 4 from it. So what we have here, the T plus 6 represents Steve, because Carl is 4 years younger than Steve. So we subtracted 4 from that age. Now, of course, T plus 6 minus 4. Is there anything to do inside those parentheses? No. Is there anything I can do to those parentheses? No. So I take the parentheses away, and I can combine. The T is going to stay the same. Positive 6 and negative 4 becomes positive 2. So now this is Steve, which is T plus 6, plus Tom, which is T, plus Carl, which is T plus 2, adds up to 50. And from here we're going to combine. What's this combine to on the left side? Perfect. We've got 1, 2, 3 T's, so 3T plus 6 and 2 make 8 equals 50. What's next? Careful. Subtract 8. There we go. 3T equals 42. Now we can divide by 3. T equals 14. So Tom is 14. Steve is T plus 6, so 14 plus 6 is 20. And Carl is T plus 2, so 14 plus 2 is 16. Do those add up to 50 if I add them up? Sure do. So let's have you guys try one. Kim is 5 years older than Sam. Phil is 3 years younger than Sam. The sum of their ages is 32. Find their ages. I'll pause and give you guys a minute. So, we've got Kim, Sam, and Phil. Where do you start? Sam's going to be S. Kim will be S plus 5, because Kim is 5 years older than Sam. Okay, what's next? Phil is 2 years younger than Sam, or 3 years younger than Sam, sorry, so Phil is S minus 3. So in this case, they both reference Sam. They're both defined in terms of Sam. So then what's our equation? Perfect. S plus 5, which is Kim, plus S, which is Sam, plus S minus 3, which is Phil, equals the sum, the total, which is 32. What's that reduced to? Good. Perfect. S plus S plus S is 3S. And 5 and negative 3 makes a positive 2, equals 32. Then what do we do? Subtract 2. 3S equals 30. And then divide by 3. S equals 10. So that means Sam is 10. Kim is S plus 5, so 10 plus 5 is 15. And Phil is S minus 3, so 10 minus 3 is 7. And yes, that does add up to 32 if we double check it. Okay, so now the next thing on our list is going to be a review of working with our variables again. Some things I want to talk about. We've looked at our algebraic numbers, like 4y, 4x, whatever. And we've defined that that is a count and a name. That the 4 is telling us how many, our count. And the y is the name, telling us what it is. Just like having 4 inches, 4 pounds, 4 sevenths, any other number. But we've also seen that we can have different powers on that variable. 4y and 7y squared are not the same name. Now, one of the things that we will define about these variables is something called the degree. And the degree is the power. So this here would be a second degree, or a degree of 2, because it has a power of 2 on it. So if I have something like 7x to the 5th, what degree is that? It's the 5th degree, or degree of 5. Where it gets a little foggy is if I have more than one variable. So if I have something like 3x squared y to the 3rd, what degree is it? Well, whichever one is larger. I mean, different books handle it differently. For this textbook and for our purposes, we're just going to take the larger power. So this is a 3rd degree. It is possible to ask what degree in the variable x, what degree is this? Well, then you would go with the power on the variable x. That's terminology that isn't horribly useful for us in this course. But if you were to go on and take a college algebra course, you would get into graphing and graphing different forms of equations, and a 1st degree equation, 2nd degree equation, 3rd degree equations that each have a very distinct shape on the graph. So knowing that degree helps you with that task. For this class, we're not going to get that far into it. We're just going to look at graphing lines, maybe parabolas, 2nd degree. Each of these has 2 distinct parts. What we called the name is often called the coefficient. The coefficient is just the name, what we call the count, I should say. Technical difficulties got me confused. That's the count. That tells us how many. The coefficient is just the number that multiplies the variables. And then, of course, our name is the variables. When we write these, we've talked about this a little bit before. Just like when we write any number, if I were to write 743, we talked about the full form of that number. This is 7 hundreds plus 4 tens plus 3 ones. Even though we could write that in any other order, it would be the same number if we wrote 4 tens and 3 ones and 7 hundreds. Still the same number, it's just awkward to look at it. That's because when we write out digits, we tend to write digits in something called descending order. We've talked a little bit about powers. Hundreds are 10 to the second, tens are 10 to the 1, and ones are 10 to the 0. So when we say descending order, we're talking about the largest place value down to the smallest place value. Or if we're looking at these, we have a decimal system or base 10 system, those place values are powers of 10, going from the highest power of 10 to the lowest power of 10. So when we have algebraic numbers, we tend to do the same thing. While it's perfectly acceptable to have 23x plus 7x squared minus 18, it's just considered more correct. Think of it as math grammar, if you will, to put it in descending order. 7x squared plus 23x minus 18. Because that's how we write all of our numbers, is largest place value to smallest place value. And if you recall, we compared these variables to our place values. Up here, it was 10 to the second, 10 to the 1, and 10 to the 0. Here it's x to the second, x to the 1, and x to the 0. There's no x written there, but remember, x to the 0 is just 1. So as we go to work with these, a little bit of review. If I have 5x to the third minus 18x plus 7 plus 2x to the third plus 5x minus 12. In your notes, see if you remember how to combine those for me. So if you write out the first one, when we write out the second one, we line them up. So the x to the third goes under the x to the third. The x's go under the x's, and the ones go under the ones. And this is adding down the columns. You'll note here that I did go with x to the third to start off each of them. It doesn't matter as long as they're the same. I didn't have the x squareds in there, but there wasn't in either number, so I don't have to account for it. Next example, I'll show you how to deal with that if there's one and one and not the other. 7 plus negative 12 is negative 5. Very good. Positive 7, negative 12. Let's get negative 5. Negative 18 plus positive 5. Negative 13, and of course that's going to be x. Then 5 and 2 makes 7x to the third. When we add or subtract, we combine the counts, which is what we did with the numbers, and we keep the same names. That's why this stayed x's, and this stayed x to the third. What if we have 3x squared minus 9x minus 3 plus 4x to the third plus 5x minus 12. So I'm going to write this out. 3x squared minus 9x minus 3. Where am I going to put the 4x to the third? I've got to put it over here. It cannot line up with the 3x squared because they have different names, different powers. What I'm going to do is I'm going to fill in 0x squared here. Because there is no x squared there. then positive 5x, and a negative 12 here. And we are still adding. So we're going to start right to left. Negative 3 and negative 12 make negative 15. Negative 9x and positive 5x. Negative 4. Very good. Negative 9 and positive 5 is negative 4x. 3x squared and 0x squared. 3x squared, and since that's positive, put a plus in front of it. And the 4x to the third has nothing to combine with. In your notes, do that one for me quick, and we'll discuss it in a sec. So the first one, we have 5x to the third, then 7x. So I'm going to leave a space here for x squared. I'll put in 0x squared just in case. 7x, and then minus 8. Not totally sure if I'm going to need this yet. Actually, I looked ahead, and I know I'm going to, but we're missing that power, so it's good to put it in there just in case. Now, in the next number, we do have 8x squared. That has to line up with the other x squared. So I did need the 0x squared in there. Positive 12 is going to line up with the negative 8. So I could fill in my 0x there. If I wanted to, I could fill in 0x to the third there even if I needed to. And I am still adding these two numbers. Negative 8 plus 12 is positive 4. 7x and 0x. 7x, good. 0x squared and 8x squared. 8x squared and 5x to the third. How many of you got that? Okay. Well, the next step is to subtract, and we're at that point. We've got about a minute before break. So let's take our break early. We'll come back after break, and we'll talk about subtraction.